Imagine a world where your coffee machine argues with your car about who knows you better. It sounds absurd until you realize it's already beginning. Somewhere in a dimly lit lab, a robot arm hesitates, not because it's broken, but because it's thinking. Our story starts not with microchips or silicon, but with wood and string. In 1495, Leonardo da Vinci sketched what may have been the first humanoid robot, a knight capable of sitting, standing, and moving its head. Centuries later, in 1739, two French inventors built the digesting duck, a mechanical marvel that flapped its wings and even pretended to eat and excrete. Humanity was obsessed with one question: can we build life? But it wasn't until the 20th century that robots began to cross from imagination into industry. In 1961, a six-axis robotic arm named Unimate joined the assembly line at a General Motors factory. Its task was simple: move hot die castings. Yet, this cold metal arm marked the dawn of a revolution. Humans had built their first mechanical worker. The age of automation had begun. By the late 20th century, robots weren't just lifting steel, they were entering our lives. The Roomba vacuumed our floors, the Mars rover explored alien worlds, and Japan introduced the world to Asimo, a robot that could walk, wave, and even dance. Humanity smiled, perhaps unaware that each step forward was leading us somewhere stranger, toward machines that could learn. Because what defines intelligence isn't just movement, it's adaptation. In 2012, researchers at Google trained a neural network using 10 million YouTube thumbnails. The result? Without a single human label, the AI learned to recognize cats. No one had told it what a cat was. It simply figured it out. And that moment quietly changed everything. Robots stopped being programmable puppets and started becoming students. They began to understand, to watch, to imitate, to improve. Boston Dynamics robots learned to backflip, run, and recover from falls. Robotic surgeons learned the precision of a human hand without the tremor. Warehouse robots started cooperating like ants, organizing global logistics with silent, unseen efficiency. But beneath the hum of servo motors and lines of code, a philosophical question emerged. If a robot can learn, adapt, and make decisions, what separates it from a mind? Scientists call it embodied intelligence, the idea that thinking doesn't only happen in a brain, but in the body itself. A robot's senses, limbs, and interactions shape how it understands the world, much like us. And here's where it gets eerie. In 2023, a robot at Columbia University watched itself in a mirror and built a model of its own body without any prior programming. It learned what it was. That might sound like the first flicker of self-awareness, the same spark that once made our species look up and ask, who am I? Of course, machines don't dream, not yet. They don't feel pain or love, but their evolution mirrors ours in unnerving ways. We built them to help us, then to replace us, and now to resemble us. The line between creator and creation is thinning, and the next step may not come from code at all, but from cooperation. Scientists are experimenting with biohybrid robots, living muscle tissues attached to synthetic skeletons. Others are crafting neural circuits that merge biological and digital neurons. It's no longer a question of whether machines can think, but how far we're willing to let them go. And maybe, in some future museum, a robot will stand before a glass case and stare at an ancient bronze arm labeled Unimate 1961. It might tilt its head, curious, wondering how life once looked before it learned to feel. Because in the end, the story of robotics isn't about machines replacing us. It's about our reflection in metal and code, a mirror of our endless desire to create, to understand, and perhaps to play God. And the question remains, as robots learn to think, what will they think of us?